Greetings, welcome to part 2 of the electrical series on this van build. This is a little snapshot of where we're going to get to today. So let's get into it. Alright, now that we have our boards prepped for installation, we're going to go ahead and lay out our components with this box laying down so that we're working with gravity, not against it. I'm measuring from the top of the frame down and using a laser level to keep our lines and mount straight. We'll go ahead and attach the metal mounting bracket for our inverter to the motherboard. That's done with a few screws, and there's also 2 screws on the inside that you didn't see there. Okay, next we have 3 components. Our first bus bar, the links in, the links battery management system, BMS, and then the distributor, which is on the right side there. If I had to do this over, I would have slid this component a couple more inches to the left side of the screen to create a little more space between it and the inverter. So after pre-drilling holes and using some set screws, we got this in, which is when I moved to the switch panels and I noticed that this AC DC switch panel was right up against the inverter, and it's just barely gonna fit. Okay, after that we moved on to bench testing, and by bench testing I mean starting to take out our components one by one, add power to them with this bench power supply, and just start getting things updated, familiarizing myself with the operating system and the graphical user interface, and then of course RTFMing. If you haven't heard this term before, that means read the friendly manual. So going component by component, we're looking at the screen for the Servo GPX, and it connects with an HDMI cable to this screen. And this is the communicator for all our components. Additionally, most of these components have low-range Bluetooth, so with the VictronConnect app, we can see them broadcasting and connect to them with the default pin of 0000006 zeros. I think that's how many I just said there. So you can connect to things one at a time, which doesn't always work. So you may have to use the PUK command. Pro tip there, take photos and write down the PUK codes for all the components you attach to your motherboard so that you can reference them in the future if you need to troubleshoot a Bluetooth connection step. So getting the Servo connected to Wi-Fi is an important step, or at a minimum getting it on a network, which is what I'm doing now. I'm putting it on my home Wi-Fi network. In the future it will be on the Starlink Wi-Fi network so that it's always mobile and always on. Additionally, there is an Ethernet port, so you could hardwire it in if you're in a non-moving installation, or that just works for your use case. Just something to keep in mind. Note that Ethernet port, it's the only one with link lights. You don't need it for anything else, and it shouldn't be confused with a COM port, even though it holds an RJ45 jack. Okay, now let's get into some serious RTFMing. This is my favorite Victron manual, and I'll link it in the description below, but it really talks about the concepts of putting a system like this together. And so if you're watching this, hopefully you know about the components you're using and have an idea of how you want to put them together. Well, this manual tells you what you need to do that safely from an electrical engineering standpoint. So that's the reason I recommend you read the manuals for all these products, but definitely this overview manual. Look in my van building playlist for a video all about my favorite Victron manuals, and you'll find a video specific to that if you want more deeper information on how to find the best manuals and what to look for out there. Okay, so we got this set up, and now we're looking at the VRM portal, and it is really cool. So everything that servo is picking up is going into the VRM portal, and I can navigate that to that on a web browser. At the time of this recording, Firefox works best. And so this is a snapshot on the future of when the system's in its testing phase, where all the batteries are wired, and it has a minimal AC and DC load on it. And we're looking at what the screen in the van would look like, or boat, or what have you, off-grid cabin. In this case, it's a van. The advanced section is one that I really like. It's where you're going to get deep into all the details. One thing to pay attention to is your battery temperature, and if you're using Victron batteries, that temperature in a smart BMS, Victron smart BMS, that temperature is going to output to that and then be picked up here. Now, it's not going to show you the exact temperature. You got to connect to a battery to see that in Celsius, but it will show you if that battery's too hot or too cold. And if it's too cold, it's not going to accept charge. And you'll see that under charging accepted, it will say no. Okay, let's get back into this assembly process. So the Servo GX is one of those critical components because it lets us see what's happening on our system and monitoring it. Okay, so moving on, we're going to our battery cables. And these are aught-6. And if you don't know what size battery cables you should use, you're definitely going to want to read the manuals I was talking about to figure out how much current's going through your system. But the general concept is the lower the voltage, the bigger the cables. So in this case, we're doing a 12-volt system, and these cables are going to be capable of moving hundreds of amps of current safely. So lower voltage, higher current, higher amp, higher voltage, lower current, lower amp. Okay, so now we're getting these terminal ends pressed with this hydraulic press on here, and it's essentially cold welding them to the cable. And once that's done, we'll look at it. If it's a little loose, we'll crimp it again, which is what we're going to do. See how that's a little loose? We're going to crimp that again. Once it's crimped to where it's not moving at all, we put some insulator on there and heat it into place with a heat gun so it looks nice and handy. One big thing that I can't stress enough, it's so important, is that all your cables need to be the exact same length for your positive and negative sides. The manual goes into why this is important and how to test for that. But the lower the voltage, the less tolerance there is, right? You have about 2.5% tolerance on all systems, but 2.5% of 12 volts is a much smaller number than 2.5% of 48 volts. So cable length matters, and make sure your cable lengths are the same to prevent ripples in your system. Ask me how I know. Okay, so we're making our first cables here for the first time ever, and it's pretty cool. And now it's time to cut our cable lengths for the batteries that go together, and these are actually a little longer than they needed to be because I didn't quite account for the additional like inch and a half of space from these lugs I'm adding onto the ends. So I could have made them a little smaller, but I already cut 6 of them the exact same size, so I went ahead and used them, and they're just going to get a little bend into them when they are finally installed. Now I ran out of couplings, so for my initial test, I just wired 2 of these batteries together and put them on the shunt. The other thing I should change, and that you can do better than me, is you see the I said shunt, it's really a bus bar where the batteries are connecting to. Move those all the way to the left to make this to the right, sorry, to make the shortest path possible to the transformer. Okay, so we just got our BMS turned on, verified that's working. And so now we're just going to continue making cables, which is going to probably take longer than you think. And again, we talked about why to make cables the same length, which, as you can see here, I'm not doing. So I'm going to have to redo this work in the future once I figure out why that's so important for maintaining your battery health and the health of your inverters. These batteries are like a couple grand a pop, so you want them to last as long as you can. The inverter's cheap compared to the batteries, but if you don't have to replace it for a longer period of time, that's going to be good too. All right, so we're wiring more cables together, and in this parallel connection, all the negatives go together and all the positives go together. And we're putting the black negative cable on the far end of the battery and the red positive cable on the other end of the battery terminal. So the electricity is going to move as if it's just one battery. Now we're connecting the distributor, the Lynx distributor, to the BMS with this phone cable type cable. Negative, positive, and this is positive, and then the fuse goes in between the two. So when we're looking here, negative, and then this is positive. It's a little confusing because it's not red, but the fuse will go in between these two. So my fuse goes from here to here. These are mega fuses, and I needed to order them because I didn't have them on hand. So I went ahead and installed what I could, which was my positive and negative connections from the distributor to the inverter. And then I went to work getting the Servo GX powered directly from the BMS component, as opposed to it being powered by the bench power supply during its bench testing. So we're just using some ferrules on these and inserting them into the positive and negative power outputs from that manual. Note the part about the RJ45 connectors. So those RJ45 connectors are ones for an Ethernet cable to connect the BMS over the Victron CAN system to the Servo GX, and the other one's for a blank that just plugs in there that comes with your unit, and it also plugs into the Servo GX. So you need both the blanks and the actual Ethernet cable. Stick around and I'll point that out when we get to that stage in the process. Okay, so now we're ready to mount these other components. So we have a solar charge controller, solar alternator controller. So that's where that power is going to come into the system and go up to the bus bar. And then there's the AC units breaker, and that's also going to go up to the distributor. And then we're mounting the Servo GX this way with the ports on this side. So the cables just take 190 instead of if it was the other way, so that the writing was left to right like that, the cables would have to do 290s. So I'm always thinking about my cables. Now you'll see a lot of installations, so they go for this clean look where you can't see any of the cables because they've run them to the back side of the motherboard. I'm choosing not to do that, and I disagree with that approach, because when you can see your cables, you can verify that they're done correctly or incorrectly and get a better temperature gauge on them with a thermal camera or a thermometer as you use your system. So it's just easier to support long term when you can see everything when you open up your electrical box and system. So that's why I don't drill holes and then run cables behind the motherboard to make it look better, because it's just less functional that way. You do you though. Okay, so now we're moving out of the garage and into the van, and we are attaching this electrical box to the walls of the van with M5 bolts that are installed going into rib nuts. Next, we're gonna reinstall our batteries because we took them all out when we moved this thing, because it's pretty heavy anyway. and these batteries are like another 120 pounds, give or take. My approach is to always start with the negatives, get all the negatives first, and then the positives. Okay, next we move to the ground, and we're going to use some 6 AWG cable that is taped in green, and it's going to go straight to the van with a big fat bolt that is rib nutted in. If you're wondering about how you have a vehicle ground or a boat ground, and the list goes on, just start reading the manual linked below to figure that stuff out. Okay, these are the AC in and outs for the van, and they are a site of confusion. So we're going to spend more time on those in the future. Stay tuned and don't wire your system like I just wired that one. That was for testing purposes and demonstration purposes only. Okay, back to our batteries. We got them strapped in, so that's going to prevent up, down, forward, back movement. And then this piece of metal in the motherboard prevents side-to-side movement. All right, now we're working on this back panel, which is where our 2 DC switches are going to go and our AC switch, as well as a AC outlet that's going to help when we need power in this region, but also be very helpful in testing the system as we go through the installation process. So first things first, I'm adding a 10 gauge wire to the AC2 output, and the AC2 output on this unit is made for like a AC unit that would cool the van, or a boiler or some other high energy appliance that is only going to run when you're connected to shore power. So it would need to go into its own breaker, separate from the breakers that also run on DC power and are inverted. So I went ahead and wired this up for testing purposes. And a couple things I'm going to note. Any final install out of these terminals should be with 6 AWG wire and 18 millimeter ferrules. So you need to strip 18 millimeters, almost 2 centimeters of exposed wire, get them crimped with ferrules, and put them in those holes. You just need to look at YouTube for a little bit to see some war stories of inverters that have melted because wires gotten hot and melted and caused smoke or fires and destroyed electrical systems or the inverter before it could ever be used. So just keep that in mind when you're looking at this, and stick around. We'll get it right eventually. Additionally, I want to talk about service loops. So people will typically add extra wire between the entry gland crimp and the female ports. And that is so that you have a level of future proofing, and so that there's no tug on those wires below that crimp where it's pulled laterally towards the wall of the van. Okay, so now we're installing this AC DC panel, and you'll see it's full of breakers. That's going to change soon. We're only going to use the breakers we need, and we're going to switch to tandems. The other thing is the hot bus bar on the AC side is broken into 2 pieces, and so we're just going to use the bottom piece with tandems. We're not setting this up as a 2-phase system. Originally I thought I was, and it's because I thought I purchased the type of inverter that allows for a 2-phase input and a 2-phase output, and I did not buy that type of inverter, and I did not realize that, even though it should be very obvious with only 3 output legs, positive, negative, and ground. I didn't notice it until later on in the build process. So those mistakes happen when you're a new guy, and they happen to me. So I learned from it after I identified it and rectified the problem, and then moved on. The first thing I added was the max air fan, because it's a low amp appliance that's installed and ready to go, so it's perfect for testing this new board. Max air fan pulls a max of 5 amps. 1 to 5 amps is its range, so we're going to fuse it at 7.5 amps. And document that right here. Now I'm going to wire in the rest of these connectors. So for my rough electrical, I didn't have enough length on the DC connectors from the max air fan, so I'm using these solder connections, and now we're done. These work best with small wires and not big wires. Big wires, Wagyu connectors are your way to go. Okay, now we're installing the second DC panel, and these have breakers built in. After pre-drilling, we screwed this panel to the board, and then we added a negative bus bar and ordered a positive bus bar because you need both with this setup. Back to our links distributor, we went ahead and changed the positive cable so that it's the exact same size as the negative cable. Additionally, we have a 400 amp mega fuse connecting the positive to the positive. Now that the circuit is fused, we will move on to making some 6 AWG cables that can attach from the components, in this case the solar charge controller and the alternator controller, to the bus bar. So you have ferrules on one end and you have lugs on the other end. For the solar charge controller, we have a 50 amp mega fuse, and for the Orion solar charge controller, we have a 30 amp mega fuse. That's still in the mail, so we're going to use a 50 amp for now until that part comes in. Moving on to our DC circuits. Negative, positive, positive, negative. Negative bus bars under there. So in this case, the negative coming in is black, but the negative that came with this panel is white. So we're mixing black and white to make negative. Then we turn our system on and check voltage. The reading is 14 volts. So we got our max air fan wired in and working. That'll be very nice because it's pretty high humidity here in the winter, so we'll just leave that running and it will keep the humidity down. Alright, that was a lot of work and a lot of learning for part 2 of this series. Please stick around for the next episode where we continue on our journey.